Science Beetle.
Hey, welcome back, students, to Math 101. Today we're going to be covering factoring. And let me just get the definition out in the open so that we're aware of what factoring really is. So whenever we talk about factoring, what we are talking about is when you identify, so when you ID all possible numbers that produce a number that you want. Okay? So let me show you an example of what this really means. So let's take the number 115, for example. So if I write 115, all I'm asking is what numbers can be multiplied with one another to give you 115. So some of the possible answers here is if I take 1 and I multiply it by 115, that will surely give me 115. Can I do another number? Well, there's various numbers here, and sometimes the way you kind of figure this out is just by doing trial and error. But if you do just some simple techniques here, you can figure this out. The first thing that you need to do is you look at the 5, or the last digit. Since this digit ends in a 5, it tells me two things. One, it's odd. So that means that if I try to multiply it by a 2, I'm almost always going to get a fraction. And when we're doing factoring, what you want is whole numbers. So you don't... dividing this by 2 is not going to work for us. The other thing that the 5 tells us is that it's going to be a divisible by 5. So 5 multiplied by some number will give you 115. Now there are some other tricks that you can do, and also since we're trying to figure out if it's divisible by 3, we add all the numbers. So essentially what I would do is I would take 1 plus 1, that's 2, 2 plus 5 is 7, so 7 divided by 3 is going to be a fraction, so it's not divisible by 3. Okay? And so what we want to do is then just go in and repeat this. The other thing you can do is just write them all out. So since I know that 5 is going to be a 2 is not going to give us a whole number, and so any multiple of 2, like 4, 6, 8, 10, is not going to produce anything that's going to be worthwhile to us because it's going to give us a fraction. 3 is not going to work because it's not divisible by 3. If 4 is a multiple of 2, so that's not going to work. 5, we know that 5 will work. Why? Because of the 5 here at the very end. Let me just underline it again. Because of that 5, so we know that we're going to be able to factor this out by 5. So 5 times some other number is going to give me 115. And if you're not entirely sure what that is, go ahead and write 115 divided by 5. And we know that 5 goes into 11 2 times. That'll give you 10 there. And then 5 will go into 15 3 times. So the answer here would be 23. These two numbers will give you 115. And that pretty much does it. So the factors then that we're looking for are going to be the following factors. And let me just circle those. These are all the possible factors. So when I come back over here and I try to answer this question, what are the possible factors of 115? I'm going to write 1, 5, 23, and 115. Those are all the factors of 115. Okay, let's try another one. So let's pretend that I've got 81 and I want to find all the possible factors of 81. Okay, so what I'm going to do is I'm going to kind of start off at 1. So I know that 1 times 81 will give me 81. Can 2 go into 81? Well, since I know that the 81 here, let me rewrite it over here in the corner, 81, I know that this digit here is odd. So if I always try to divide an odd number, I'm always going to get an odd. There's not enough. It's not evenly split. So any multiple of 2 then is not going to generate any kind of worthwhile factor here. So 2 is not a good answer here. So what if I do 3? Well, remember the shortcut. So if I do 3, one of the shortcuts is if I add the 8 plus the 1, that gives me 9. Can 9 be divided by 3? Yes. So one of the factors there, 3, is going to be a factor of 81. So if I do 81, let me just erase this again, and let's do this longhand. 81 divided by 3. How many times can 3 go into 8? 2, 6, and 3 into 21? 7. So 3 times 27 will give me 81. There's another factor. Can I divide the 3 any further? No. 3 can only be divided by itself and 1. And how about 27? Well, I know that 27 can be divided by, I can go 3. And if I do that, 9 would give me a 27. And can I divide the 3 any further? Nope. How about the 9? Yep, I can definitely do 3 times 3. So what you've got here are all the possible factors. Now, we don't want to put all of these, repeat all numbers over and over again. So what we want to do is identify those numbers that only repeat once. So here's 81, the 3, a 27, the 9. Since I've already got these 3 here, I don't need to repeat it because I've already included it there. So the answer, or the factors of 81 here, let me erase this. So the factors of 81 then are going to be the following. So the factors of 81 are 1, 3, 9, 27, and 81. Now keep in mind that the steps that I'm using here to identify these factors, this structure that I've drawn here, this is called a factor tree. Okay, and so let me write that there. And the factor tree can help you identify all the factors in a given number, but it can also help you find another type of factoring called prime factorization. In prime factorization is essentially a factor tree that clearly identifies all of the prime numbers. And so if you're not familiar with what a prime number is, let me define that for you. So a prime number is going to be a number that is divisible by 1 and itself. Those are the only two numbers that can divide it. So when we go through this problem that we just did for 81, are there any prime numbers in this one, in this factorization that we've got here? Well, there is. And so let's go ahead and identify these. I'm going to circle these in orange. So 1 can only be divided by itself and 1. 3 can only be divided by itself and 1. And so that makes all these other 3's the same thing. Now, is 81 a prime number? No, because it can be divided by 3 and 27, so it's not going to be a prime number. 27 is not a prime number because it can be divided by 3 and 9 and 1. Same thing for 81. And 9 is not a prime number because it can be divided by 3, a 3 and a 1. So none of these are going to be prime numbers, 81, 27, and 9. But the 1, 3, and all the other 3's here are definitely going to be prime numbers. So when we look at the prime factorization of a number, what we're looking for is all these prime numbers. So the way we would identify that would be the following way. We would say that the prime factorization, so I'm going to write it like this, prime factorization of 81 is going to be 1, 3, times 3, times 3, times 3. In fact, this is not a comma, but rather this is going to be a times. So 1 times 3 times 3 times 3 times 3 is going to be the prime factorization of 81. In a later lesson, you're going to see why this is very important when we start getting into exponential numbers and when we start to identify the greatest common multiples or the greatest common factors or the least common factors or the least common multiples. Okay? So hopefully this lesson was very helpful for you. Go ahead and subscribe us, and we'll see you at the next lesson.